Okay, guys, now we're going to talk about the lifetime of variables. And you'll understand what I mean by that in just a second. But let's insert a module. So I'm going to go up here on the toolbar, insert module. I'm going to rename this module in the properties. I'm going to call it scope of variables 1. So now we have this blank module, and I'm going to insert a subroutine, and I'm going to call it sub. I'll call it var variable scope. So here I have a subroutine, a macro. And we've seen before that we can do things like declare a simple variable like dim x as integer. And we can assign to that variable that can hold integers by doing something like this: x equals x plus 100. And what's important to note about this variable is that this variable, well, let's put it in a message box. So if we do msgbox x, and I'll put some words in here. I'm going to put x in sub 1, and then I'm going to append the value x. So let me explain this in a second. Let me change the name of this subroutine to sub 1. Okay, so what am I doing here? I'm declaring a variable that can hold integers. I'm assigning the variable whatever its current value is plus the value of 100. So if the value is 0, it's going to be assigned 0 plus 100. And then I have a message box that reads x in sub 1 is equal to the value x. And I'm going to put a comment over here that says this variable dies when sub 1 ends. And by what I mean by dies is that it's erased from your computer's memory when this subroutine sub 1 ends. So if we run this, and also I have the locals window here. So if we run this, let's put a breakpoint here at the end of it. And if I run it, I get the message box x in sub 1 is equal to 100. Why is that? That's because it had 0 in here originally, right? I mean, I didn't assign it anything. And then if it had nothing in it and I add 100 to nothing, then I'm going to get the value 100 into that x variable. And then the message box is just going to say x in sub 1 is equal to 100. But now when I hit run again, the variable is cleared out of your computer's memory. And if I hit run one more time, I still get 100 in here. So far, that's what we've seen with variables. The lifetime of the variable so far, we've seen that as soon as they hit end sub, it's erased from your computer's memory. And that means when you run the macro again, you always get the same values in your variable. You get 100 again, right? It's not showing 200 here and then 300 and 400. But we can do that. We can make a variable live longer than when the sub ends. So to do that, let's do this. Dim y as not dim. I'm sorry. Static y as integer. Now, what does static do? Well, static makes the variable live just a little bit longer. So we'll see what I mean right now. And then we'll see what I mean right now. Let's do the same thing. Y is equal to y plus 100, and I'm just going to copy this line, paste it in, and I'm going to put y in sub 1 is equal to y. And what's interesting about this line now is that this lives after sub 1 ends. And so if I run this now, I'm going to see two message boxes. And the first time I run it, look what happens. I get x in sub 1 is equal to 100, and I get y in sub 1 is equal to 100. Okay, that's pretty much what we expected. But watch what happens now when I run it for the second time. If I run it again, I get x is equal to 100, y is equal to 200. Now that's strange. That means that when the sub ends, when it hits that line, this value in the y variable is not being erased from your computer's memory. And what causes it to not be erased is this static keyword. So if we look into your computer's memory, if we run this again, look what happens. Y already has the value 200 in it, whereas x is 0. Why does this value exist when I just ran it? It's because it was declared as static, so it didn't get erased. So that means if I run it again, if I run the macro again, I'm going to get x is equal to 100, y is equal to 300, because I just keep adding 100 to whatever the value y is. So that's pretty interesting. Now we can make variables even last longer. So this variable y will live in sub 1 in this subroutine even after the subroutine ends. But let's say we have another subroutine called sub 2, and let me just copy these two message boxes. So now I'm going to have a message box that says x in sub 2 and y in sub 2. And notice what's going to happen here is that there's going to be no value here, and there's going to be no value here. And you'll see what I mean by that in a second. So what I want to do is I want to call this subroutine sub 2. So like we saw before, we can do this call keyword and then call sub 2, as we saw in an earlier video. So what's going to happen here? I'm going to do what I just did, and then I'm going to call this subroutine sub 2, which is going to just display whatever value is in the x variable and the y variable. And the point of me doing this is to see, okay, does x and y exist in this subroutine sub 2? I know they exist up here, and I know that y remains in the memory. But what happens across subroutines? Like here's a subroutine here, and here's a subroutine here. Do the variables exist in both subroutines? Well, let's see what happens. So if I run this, there's x is equal to 100, y is equal to 100, and then x is equal to nothing and y is equal to nothing. What does that mean? That means that down here in this subroutine, x and y, they're not alive anymore. They're dead. So using the keywords dim and static only allow you to have a variable that lives as long as the single subroutine exists, right? As long as it's in this subroutine, the variable will exist. So let's run it again, and now we get x is 100, y is 200, right? If I press the reset button and I press run, then I get x is 100, y is 100. In case you're wondering, when does y go back to being nothing? It goes back to being nothing when you hit reset, when the code is reset. Okay, so now we have two types of variables. The first variable, using dim inside a subroutine, lives until it hits end sub. The second type of variable is declared using static, it lives after, even after nsub is encountered. Now let's look at a third type of variable that will exist down here in a different subroutine. To do that, at the very top of your module, you do something like this: public, or no, you do, sorry, dim z as integer, and if I do the same thing here, dim message z in sub1 z, and I copy it down here, what's interesting here is that in sub 1 it behaves, this new variable z, it behaves like a static variable, so it lives after sub 1 ends. But down here, now it has a value. And let me assign it something, this z variable. So I'm going to do the same thing up here. Z is equal to z plus 100. So what did I just do? I added this variable z inside this sub1 macro, and I declared it above all the subroutines up here. What that allows me to do, it allows the variable to live after the nsub, so it'll behave like a static variable, and it also allows it to exist across subroutines, to be, so it's identified across subroutines. So if I run this, let's see what happens. X is equal to 100, y is equal to 100, oops, z, oh, let me do it again. I'll press the reset button. And I noticed that I didn't press the reset, but the values were back to 0. That's because I added code here. And if you add code or change code, it basically resets. So I just hit run. I have x in sub 1 is equal to 100, y in sub 1 is equal to 100, z in sub 1 is equal to 100. Now I'm in sub 2. X is equal to, x in sub 2 is equal to nothing, y in sub 2 is equal to nothing, but z in sub 2 is equal to 100. And that's the critical point, is that right here, if I put a breakpoint, watch what happens now. X is in sub 1 is 100, y in sub 1 is 200, z in sub 1 is 200. Now I just did this stuff, right? These two variables, they contain their information after the first running of the subroutine. And now across the subroutines, I get x is equal to nothing in sub 1, y is equal to nothing in sub 1. Z, however, exists, and it exists in sub 2. So what happened here? By declaring your variable at the top, you make the lifetime of the variable exist after the sub ends, and because it's at the top, you allow it to be available across subroutines, like down here in a different subroutine. That's why I put a comment has a value, because declared at top. Okay, so now we have variables that do many different things. We have three types of variables. This one, which dies when sub 1 ends. This one, which lives after sub 1 ends. And I should put, but not seen in sub 2. And this one is seen in sub 2. Right? So we have three types of variables. One dies when the sub ends, one lives after, but it's not seen in the subroutine 2, and the third one lives after sub 1 and it's seen in sub 2. Okay, so now we're getting places. We can have variables that can live across different places, across subroutines and after nsub. We have one more variable type, and for that variable type, I'm going to need to insert another module, so I'll go here, I'll go insert module. I'll bring that properties window up, and I'm going to call this module scope of variables 3 or 2. So here I have a scope of variables 1 with the code we just saw, and scope of variables 2. So now what I want to do is declare in this scope of variables 2, I want to declare a subroutine. And I'm going to call it sub global variable. And over here, back in this bit of code, I want to declare a global variable that will be seen across modules and subroutines. So to do that, I'm going to do this: public q as integer. And I'm going to do the same thing. I'm going to do q is equal to q plus 100, and then set up a message box again in subroutine 1. So there's q in sub 1, q. And this is going to live after sub 1 ends, and it's seen in sub 2, and seen across modules. So this is like the variable that can be seen anywhere. It can be seen across subroutines, and it can be seen across modules, and that's because it's declared as public at the top. So let me copy this message box down here for q, the q variable. There's q in sub 2, and again, this is going to be seen. It's going to have a value because it's declared public at top, and this one up here was declared dim. Dim at top. But also, I want to check that what happens to these variables as they go across modules. So let me copy this message box code here and put it over here as well. Now I have a different module, and I'm going to check what these values are. And this is the second module, right? Because here's the first module, here's the second module. What we want to test is all the variables that we create here, do they exist in this module? And only this one is going to exist, q, because it's public. It's declared as public on the other module. So here we go, module and second module. And what I just said is that all these are going to have no value. The first 3 are going to have no value. And this last one, q, this q variable, is going to has a value because declared public. Okay, so we have to call this subroutine, and I want to call it over here. Call global variable. Okay, so now we're going to have 12 message boxes that we're going to pop up. We already seen 8 of them. The first one is in here, where all the variables are going to have values, right? Second one is in here, where only 2 of them are going to have value. And the third one is in here, the third set of message boxes. Only this one is going to have a value. This one has a value because it's declared public up here, right here. And then we're going to notice some other things, is that which variables hold their value across subroutines. Well, after the sub ends. This holds its value after the sub ends. So does this. and so does this. So these three all hold their values after the sub ends. So let's run this, and hopefully you'll see what's happening here. So when I run it, I get x in sub 1 is equal to 100, y in sub 1 is equal to 100, z in sub 100, q is 100. Now I'm in sub 2. I don't see x, I don't see y, but I see z, and I see q. Oops, let me, I have, here, I want to change this. This shouldn't be 2, it should be q. Okay, so let me put a breakpoint here and a breakpoint here. I'm going to press a reset button. Let's run it now. So in sub 1, x has a value, y has a value, z has a value, and q has a value. They're all available, and they all have values in sub 1. Now let's go down here in sub 2 and see which ones we can see, which variables we can see. And the ones we can see are the ones that are declared at the top. So we can see this one because it's declared at the top, so we can see it across all the subroutines in this module. And this is public, so we can see it anywhere. So if I hit run, in sub 2, x doesn't have a value, y doesn't, but z and q do. Now, if we go into the global variable over here, now we're crossing over into a different module, right? This global variable exists, this global variable subroutine exists in a different module. What variables can you see in different modules? The only one you're going to be able to see is this one, the q, because it's declared public. So if I click run, in the second module, x has nothing, y has nothing in the second module, z has nothing in the second module, and q has a value. That's the one we could see. Okay, so now we just saw that by putting public at the top for this variable q, I can use it across modules. That's even a bigger scope. That has a bigger scope than this variable, which can be used, the z variable, which can be used across subroutines. So there's a couple things to note here. If you want to use variables across subroutines, then declare your variable like this. If you want even a bigger scope, even bigger use of your variable across subroutines and modules, then declare it as public up here. And notice when I run it again, I get x is equal to 100, y is equal to 200, z is equal to 200, and q is equal to 200. So there's a remaining, the value in your memory of the last three variables, you know, these three variables, they're sticking around in your memory. So that's the other thing to note, is that static makes the variable stay in the computer's memory. And so does when you declare a variable at the top using dim, and so does making it public. They all make the value, whatever it is, stay in your computer's memory. So you can see there's the value staying in your computer's memory. And then if I run this one, let me just take this off. The only one that you're going to see here is q the only one you're going to see across modules is q. So this is sort of, I don't know if it's confusing. I don't think it's confusing. It's just what it comes down to is, where do you declare your variables and what word do you declare them with? If you declare your variables inside of a subroutine like these two, then they're only going to be used inside of that subroutine. If you want the variable to keep its value and only be used in the subroutine, then use the word static. But remember, if you use static inside a subroutine, it's not going to be seen in a different subroutine. If you want your variable to be seen across and to be used across subroutines, you do this, dim z as integer, and then you can see z down here in a different subroutine. But if you do that, you won't be able to see z over here in a different module. if you want to see variables across subroutines and modules, then you want to declare the variable public at the top like this. So, in summary, this video is about the scope of variables, or the lifetime. How long do they live? How long do they last? This, declaring a variable inside a subroutine with just dim, has the shortest lifetime because it only is in the subroutine you declare it, and it only lasts until the end subline. This has the next biggest lifetime because it lasts after the subroutine. This has the next biggest one because it's available across subroutines, and this has the biggest lifetime or scope because it's available across subroutines and across modules, and it retains its value in memory. So that's the idea of scope of variables or lifetime of variables. You're not going to use this too much, to be honest with you. You won't be using this too much. It's nothing to get freaked out about or hung up on, but you should be aware of it, and you should be aware of what this static does, and you should be aware of what this does when you use dim. When you declare a variable with dim at the top, it makes a variable available across subroutines, versus what this does if you declare a variable public at the top, which makes the variable available across modules. So that's it for this video, and in the next video we are going to start talking about how to add parameters to our sub-procedures. And up until now we sort of focused on the environment and variables and things like that. We need to know this stuff because if you're going to write code, you need to know how these variables work and how they work in memory. So that's it for this video. In the next video we'll start picking up speed, and we'll start writing sub-procedures with parameters and functions.